My group will present mini project. So the mini project that we made is a washing machine. So before we start, okay, let's go. So this is our group members, which is Amir Shakirin bin Burhanuddin B0122102773, Andre Xavier Avid Anget B0122100176, Danish Kumar anak lelaki Baskaran B0122100274, and which is me, Muhammad Syami bin Zaid B0122100086.
Okay, thank you, Shami. So I'm Andre. Good evening, everyone. Let me present the problem statement for our washing machine project. So firstly, convenience. The system should prioritize user convenience by enabling remote operation and minimizing the need for constant user supervision. Users need a system that's easy to use with remote control to reduce supervision and save time. Secondly, automation. The washing process, including washing, rinsing, and draining, should be fully automated. The machine must handle washing, rinsing, and draining automatically for a seamless experience. Thirdly, time management. Precise time control is crucial for effective washing and draining cycles. So this precise time control ensures efficient and timely washing cycles. So for the fourth one, water level control. It is to measure accurate water level management. It is essential for proper washing performance and efficient water usage. Our project addresses convenient automation, time management, and water control for an efficient and user-friendly washing machine. So next, Amirul.
Okay, so I will continue this objective. So the first one is to design the washing machine by using IDE 68K as our assembler and simulator. This involves utilizing the IDE 68K development environment, which support assembly language programming to create the system logic. The IDE 68K platform is used for assembling and simulating the core function of the washing machine, such as controlling its different operational mode. Second, to determine the input and output of the system by using visual simulator. So, uh, input for the system could include user command like setting washing mode, water level, or time setting. Output might include signal to control motor speed, water inlet and outlet valve, or display indicators. And the next is to design a time-based system to control the washing machine. Time-based control system ensure the washing machine process. Example, washing, rinsing, spinning are executed for predefined duration. This system involves creating precise timing algorithm to regulate each cycle, optimizing energy efficiency and maintaining reliability. And lastly, to ensure the convenience of the system to the user. User convenience is prioritized by designing a user-friendly interface and ensuring seamless interaction with the washing machine features like intuitive control, clear feedback to indicator or display screen, and preset mode simplify the user experience. Okay, next. Next is methodology.
Right, thank you, Shami. I'm Amiro, so I will be explaining about methodology. Okay, first, as you guys can see, in the methodology starts with the software IDE is operated with the first step, which is executing the IDE 68K icon and then creating a new file and save. The second step is the component needs to be defined as shown in the coding, and the address was assigned as shown in figure or in the coding in our slide and our report. which are indicated by switch, EQU, and so on and so forth. The third step is the starting address, as also indicated in our report, in our coding report. Fourth step is we show how many times the program start to pre-code it all over again to get 3 times of washing. The fifth step is we start subroutine with the duration for washing, draining, and spinning, and then the status of the switch is checked. So if the switch is on the software, it will go to fill subroutine to fill the tank. So it will start by washing, draining, spinning, and then it will follow the step as we assign them in the coding. So the next step is fill subroutine. There is a code that shows fill on 7 segment, as you can see in our report. During the filling operation, in the fill subroutine, the level water is checked using a mean of sensor presented by a slider for the purpose of the simulation, also shown in the report. When the tank is filled, the software will go to wash subroutine automatically, and the operation of the motor here is represented by an LED simulation as shown in our report also. Next step is the software goes to wash subroutine, and the wash operation start the wash as shown in the 7 segment. The duration of the wash has been set in the start subroutine and is called by the address D5. When the countdown duration is done, the software goes to the next routine, which is the drain subroutine, and the operation of the motor here is represented by the LED for the purpose of simulation. The next step, which is the 7th step, is the 8th step. The software goes to drain subroutine, which shows drain in the 7th segment. The duration of the draining has also been set in the start subroutine and is called by the address D6. When the countdown duration is done, the software goes to the spin subroutine automatically, and the operation here is represented by an LED for simulation. The 9th step, which the software goes to spin subroutine, spin is also shown in the 7th segment, and the address is shown by the D7. When the countdown duration is done, it will go automatically to the done subroutine, and the operation of the motor here is also represented by LED for simulation. Last but not least, the 10th step, after the spin subroutine, it will go to the done subroutine, which is also shown on the 7th segment as done. Then a sound is produced to notify that the process is done. After that, the software goes to the off subroutine to check the state of the switch and clear the display, and goes back to start. Thank you. Next.
Okay, my name is Dinesh Kumar. I'll be presenting on the source code. The source code is divided into 4 parts, where at first the code begins by defining the memory map I/O location for various components of the washing machine. The switch is defined as located at E001, which represents the switch used to start the washing cycle, and LED located at E003, used to control the LED indicator, and slider, which is at E005. A slider is used to measure the amount of water that we use. For the second part, the program start and the filling phase is begin. The program send out the characters FILL to a display at addresses from E011 to E017. This corresponds to the 7 segment display. For the next page of the slide, we have the third part, which is the washing phase and the counter phase. The wash phase display shows WASH on the 7 segment display. The program uses GSR blink to blink the LED on and off. It discrements to the wash duration D5 with the sub.L 1 to D5 and check if the wash duration is complete. And the counter phase, the program subtracts 1 from the counter D0 and checks if the counter reaches to 0. If the counter reaches 0, it will proceed to the spin phase. The spin phase will display shows of SPIN. The LED will blink again during the spin cycle. It discrements the spin duration D7 with sub.L 1 to D7 and continues spinning until the duration expires. And finally, we'll go back to the washing cycle. It calls the GSR off to handle turning off the switch and displaying the final result, which is the off phase. It checks if the switch has been turned off by comparing the switch to DO. If the switch is still on, it loops back to the CDIS. If the switch is off, it clears the display by resetting the 7-segment display values at E11 to E019. Next will be the presentation of the actual module that we did by the software, using the software.
Okay, can proceed.
Okay, this is the visual simulator of the washing machine. I will start the program now. As you can see, the switch 0 will switch on, and we are now in the fill state as the 7-segment display is showing. The slider is indicated for the amount of water. Once the water is filled up, it will switch to wash mode. After the washing is done, take a few minutes for each cycle to run. And now we are, after the washing cycle, we'll go to the drain cycle, the drain phase. The LED will be indicated by blinking. And now after the next cycle, you'll go to the spin cycle or spin phase, you can say. Once the spinning cycle is done, it will complete. The whole cycle will be complete, and the switch, once you switch it off, the 7-segment display will reset by reducing the slider to 0 and starting back the switch. We'll once again start the cycle. That is all for the visual simulator. Thank you.